We will start graphing inverse trig here very soon. Not right now, but at the moment we just want to figure out how to solve trig equations, which requires us to do the inverse of them. So we know how to do questions like number 1 here, cosine theta equals square root of 3 over 2. How do you do it? You get theta by itself by doing the inverse. And some of you guys have already been accustomed to writing plus minus, and that's fine. I think that's because I told you guys to just write plus minus all the time. That's fine there. And then you can get your theta 1 by doing arc cosine of square root of 3 over 2 in the calculator will give you pi over 6. And yeah, this is true. Plus minus pi over 6 is square root of 3 over 2. Cosine of pi over 6 and cosine of negative pi over 6 will both yield the same value, square root of 3 over 2. So plus 2 pi n. And I should have written theta 1 there. That's your general equation. And then your specific equations that will give you guys all the answers is theta 1 equals a positive pi over 6 plus 2 pi n. And theta 2 equals a negative pi over 6 plus 2 pi n. Where theta is equal to, they want all the answers between 0 and 4 pi. So the first answer is pi over 6. That comes from equation 1. Pretty straightforward. The next one comes from equation 2. Negative pi over 6 plus 2 pi. So you can consider that 2 pi like a 12 pi over 6, because 12 divided by 6 is 2, right? So 12 minus 1 is 11. So this is 11 pi over 6. That comes from equation 2, or just knowing that 11 pi over 6, cosine 11 pi over 6 is square root of 3 over 2. And then just keep adding 2 pi, guys. So you can turn this dude into 12 pi n over 6. And then you can just go 12 plus 1, that's 13. So 13 pi over 6, that's coming from equation 1. And then add 2 pi to the 11 pi over 6. So just add 12 to the 11. 12 and 11 is 23. And I believe that's it. Because if you add another 2 pi, you'll be above the 4 pi. Cool or not cool? Yeah. So whenever you see this restriction up here, guys, that just means get all the values between 0 and 4 pi. And that's it. That's it. That's all you do. Did you need to use a formula for this one? No. You could have gone right to the unit circle, and you could have gotten like, oh, theta 1 is equal to pi over 6 plus 2 pi n, which you have there as theta 1 anyways. And you could have said theta 2 is 11 pi over 6 plus 2 pi n. Remember, where n is an integer. You could have done that if you know your unit circle, and you didn't have to say negative pi over 6. But regardless of how you do it, you'll get the same answer all the time. Yay or nay? All right, so now you're going to need your calculator, guys. So on this one, so I'll take out my calculator as well. Yeah. Oh, just put it right there, and then grab one that has. Yeah, just I'll fix on this. So on this one, guys, this is not a perfect coordinate. So when I mean perfect coordinate, it's like a half, a square root of 2 over 2, a square root of 3 over 2, or a 1. So if it's not a perfect coordinate, then just use, there's actually 2 ways to do it. Use your formulas, or I guess you could also use logic and find the reference angle and look at the quadrant where it's positive or negative, whatever it may be. So here we go. See, there's so many ways to do it. It just depends on your understanding of it. This will always yield all the answers. Always, 100% of the time, all the time. Cool? And then you just go to your calculator, make sure you're in radian mode, and it is. See, my calculator looks like your calculator. And then I just go second arc cosine 0.9, I push enter, and I write plus minus 0.45102, truncated. So I'm going to write theta equals plus minus 0.45102 plus 2 pi n. And then theta 1 equals a positive 1, 0.45102 plus 2 pi n. And then theta 2 is equal to the negative 1, the negative 0.45102 plus 2 pi n, where n is any integer. And then if you want to know what 4 pi is, like 12 point something, in decimal, 4 pi. 12.566. 12.566. So all the answers between 0 and 12.566. So the first answer is 0.45102. The second answer is you take that negative 1 and add 2 pi. So here is that negative 1. Enter. Oh, that's not negative. Negative plus 2 pi. Perfect. 5.8321. 5.8321. Calm down. And then take the 0.451 and add 2 pi to that. So, yeah, 6.7342. 6.7342. Oh man. Comma, at least 3 digits after. And now let's take the 5.83 and add 2 pi. Scroll. And I believe this is the last one. 12.1153. 12.1153. And that's it. If you add the other one, it'll be above 12.566, which is 4 pi. How do we feel, guys? Pretty simple? Straightforward? All right, here we go. You guys also know how to solve problems like this. Relax. I'm trying to show you guys different ways to say restricted domain. So this means x is a subset between 0 and 6. So it means I want all my answers between 0 and 6. That's all it means. So let's go ahead and start. Start by writing out your equation. 3 cosine pi x equals 1. And the pi x should be in parentheses, but no big deal. I want to isolate the x. So the first thing I do is divide by
3.
Yep. So you're going to have cosine pi x equals 1/3. That's not a perfect coordinate, so we're just going to have to use our calculator here. So how do I get rid of that cosine? Yep, inverse cosine, put plus minus in the front. 1/3 plus 2 pi n. And next you're going to divide by pi plus minus. Yes, I like to write it as 1 over pi because it looks cleaner, but you don't have to. That 2n there, hopefully you're not shocked. That's because your b is pi. So this on the left hand side, 3 cosine pi x, it repeats every 2 radians. If you want to know your period, right? Period is equal to 2 pi divided by pi, which is 2. So you shouldn't be shocked of why it's 2n. So here we go. x1 is equal to the positive 1. So I'm going to go ahead and take my calculator and I'm going to clear it. I want it to look exactly like it looks on my paper there. So I'm going to put that little fraction feature, put 1 over pi. You don't have to do it like this. You can just do arc cosine of 1/3 and whatever that is divided by pi. But I like to do it like this. Second arc cosine 1/3. Push enter. So I got 0.39182. And since there's nothing in front of it, 0.39182. Travis, what do you mean by nothing in front of it? I mean there's nothing in front of the plus minus. So 1 plus something, 1 minus something. So x2 is the same thing but negative.
And the x would act as a data symbol, right?
Say that again?
So the x would act as a data symbol, right? Like
Yes, yes. We can actually make the independent variable whatever we want. Theta, alpha, gamma, omega. But yeah, we use x in this case. X and theta is the most common ones. Alright, from there we just get our answers. X equals 0.39182, comma, and let's see, negative 0.39 plus 2. So I'm going to take my little calculator here. Negative that guy plus 2. 1.608. Then you take the 0.39182 and add 2. So you can just change the 0 to 2. 2.39182 plus 2. And then take the 1.608 and add 2 to it. So 3.608. And we still got more answers because we can go all the way to 6, right? So take the 2.39182 and add 2 to it. So 4.39182. And then take the 3.608 and add 2 to it. So 5.608. And I think that's it. If you add 2 to the 4, you'll be above the 6. How do we feel, math crew? Pretty basic. Now all we got to do is learn SQL, and we can retrieve SQL programming, and we can give all of you 6-figure salaries.
Yes.
All right. So you guys are now pros at solving inverse for cosine. What about others like sine, inverse sine, and arctan? That's what we're going to find out right now. Let's put a little logic. Let's first do one with a perfect coordinate. So I have here sine equals a half. So using just, I'm going to write theta equals arc sine a half. Notice that I didn't write plus minus. I did not write plus minus because that is specifically a property of cosine. Cosine of pi over 6 is square root of 3 over 2. Cosine of negative pi over 6 is square root of 3 over 2. So a side note. So don't write anything down. I know you guys are visual learners, so you need a picture.
Oh, it's the sine of the y-axis.
Yes. So if I talk about plus minus, cosine pi over 6 will give you square root of 3 over 2, because that's what this is right here. Square root of 3 over 2 comma half, and over here, square root of 3 over 2 comma negative half. So cosine of negative pi over 6 is also square root of 3 over 2. So that's why there's a plus minus in front of the inverse for cosine. But for sine, sine of pi over 6 is a half, and sine of negative pi over 6 is a negative half. Notice that it does not work. Cool? So if sine does not have a plus minus, that's the most common mistake you guys do. So just by looking at the unit circle, where else, so I'm going to write theta 1, sine is a half where? At pi over, we just said it, pi over 6, so plus 2 pi n. And then where's the other one? Perfect. Notice that you did this with no formulas, just knowing the logic. Cool? All right. But Chavez, I want a formula, darn it. And I'm not leaving this room until you give me a formula because I want my education. Okay. If you're going to be super like that, I will give you a formula. Thank you, miss. Appreciate it. So here we go. So put your pencils down. Because right now I just want you to take this in here and absorb this. Okay. Do you agree that the reference angle on both of these are pi over 6? Yeah. And if you take this in green all the way to there, the 180, that's pi. And if I subtract the reference angle, pi minus the reference angle, will that give me 5 pi over 6?
Yeah.
Perfect. So don't write this down, just listen. So my second formula, if I wanted to use a formula, will be pi minus arc sine, don't write this down just yet, plus 2 pi n. Now why? Why, Chavez? The calculator, no matter how hard you try, the calculator will only spit out pi over 6, no matter how hard you try. So let's just first find out. So don't write this down, just listen, guys. I'm sorry if that's getting annoying that I'm repeating that 3-4 times. So sine pi over 6, 0.5, sine 5 pi over 6, 0.5, no big deal, like we got it. What is pi over 6 in decimal? Pi over 6 is 0.5235. Okay, so check it out. Arc sine of 0.5, oh, no. Yeah, 0.5. Arc sine of 0.5, I push enter, and no matter how hard you try, arc sine of 0.5, the calculator will always spit out pi over 6. So it will never spit out 5 pi over 6. But if you put a pi in front of it, so if I go pi minus arc sine of 0.5, well, this will give me the second answer. That right there, that 2.61, that is 5 pi over 6. Watch. 5 pi over 6. Enter. Do you guys see that? So if you want to be a robot, I don't recommend it. I think you should always do it with logic. But if you want to be a robot, you could always just say Theta 1 is this. And theta 2 is pi minus quote unquote this. Does that make sense? Okay, now you can write down, guys.
It's not in brackets, right?
I put it in brackets, but you don't have to. You can drop it. Oh, I'm sorry, Gonzalez. I don't really think you should get lunch detention, but you know what? How do they even keep record? Just go through the line and just keep walking.
No, but then
You have to go sit down and then you have to turn in the notes and check it.
What if you don't turn it in?
Then you get,
you get extra days, like you get another day.
Let it keep let it keep balancing.
you have to come in after school.
Then just keep.
I mean, I haven't done it, but if I did, I would.
I'm kidding, guys. I'm kidding. Don't. Do your lunch attention. Do your time.
But that's like so weird. Like other schools, it's like, oh, you've been like 5 times. You get any single time you're late.
It's what, guys. Stop. The rules are rules. You know.
Yeah, but sometimes like there is. What is your opinion about this talk?
It's fun. I'm okay with it. I got pulled over once for going 77 on a 75, and I'm like, 2 miles over, sir, really? And he's like, yes. Like, all right. And I just paid it. Like, I thought there was such a thing as a 5 mile per hour grace, but there was no grace.
There is no. You don't live in a state of trade. You're constantly like you go to fighting for our lives.
If you constantly fight the system, you're gonna find yourself wasting a lot of time.
Okay, but the thing is, sometimes the system needs you to fun.
Yeah.
Or you just be complacent.
Yeah. But was I or was I not speeding? So there it is. Yeah? All right. All right, gang of anarchists here who wants to topple the system. All right, here we go, guys. Here we go. So I'm solving this question here. Let's get back, guys. Let's get back here, guys. So it says sine theta equals 0.9, and I want all the answers between 0 and 4 pi. Remember that 4 pi is 12.566. So here we go. I'm going to write theta 1 is equal to arc sine of 0.9 plus 2 pi n, and theta 2 is equal to pi minus arc sine of 0.9 plus 2 pi n. And these two equations will give me all the answers. Chavez, why? Well, the theta 1 will give me the answer in quadrant 1, and then the pi minus arc sine of 0.9 will give me the answer in quadrant 2. And then every time I add 2 pi, I'm back at the same terminal side. Does that make sense, guys?
Yeah.
So here we go. Take your calculators. Theta 1 equals, so I'm going to go clear second arc sine 0.9, enter. So I got 1.1197. 1.1197, comma. Now I'm going to go pi minus arc sine of that. So pi, and I know I can go pi minus 1.1197, but I like to write pi minus arc sine of 0.9 again. So there it is. 2.02182. 2.02182, comma. And if you want to go ahead and write that in here, theta 1 equals 1.1197 plus 2 pi n, and then theta 2 equals 2.02182 plus 2 pi n. I think that also helps tremendously. All right, now I'm just going to keep adding 2 pi. Oh wait, is it 2 pi? Yeah. So I'm going to take that 1.11. I'm going to go plus 2 pi. 7.4029. Did I do a mistake?
No, that's what I got too, but it seems too big. I also don't know how to tell if it's big or not.
I guess as long as it's between 0 and 12.566, I think you're good. You know what I mean? 2.02 plus 2 pi. What's up?
How do you do the next one? It's like this one, so it's 8.305.
8.305.
Okay.
You can if you want. And take the 7.4. Bless you. $13.686. Nope. Then we're done. You guys should have stopped me at 8. You did, but not before I calculated it. If you think about what we did, okay, this plus 2 pi is here, and if I add another 2 pi, that's 4 pi, so we can't do that.
Well,
Man,
what did
what's
I
up?
do? Okay, wait, what did you do? So you put
Yeah, I pushed arc sine of 0.9 and it gave me 1.1197, and then I pushed pi minus arc sine of 0.9 and it gave me 2.02182. You know what I mean?
that's like the one that you added. Like add, like,
The one that I put the pi minus, because that's how, remember that I said, how do I get the answer in quadrant 2? I found my reference angle and I subtracted it from pi. Okay. Just like I did this top one here. Now, in case you're wondering, guys, can I use this formula and will it always work? It will always work, even if something is in quadrant 3. So if something's in quadrant 3, the calculator will give you an answer in quadrant 4, and then minus a negative, it's gonna be in quadrant 3. Travis, what are you talking about? Here's what I'm talking about. So don't write this down, just listen. So if I told you sine theta equals a negative half, so the calculator is not going to give you, let's see, 7 pi over 6. Theta equals arc sine of negative half. The calculator is going to spit out actually negative pi over 6. So check it out. Clear, second pi over 6. And we know this is in quadrant 4 and quadrant 3, right? So arc sine of negative 0.5, and voila, look that there's a negative in the front. So if you think about it, pi minus a negative pi over 6 is 7 pi over 6. What does the calculator spit out? Negative pi over 6. Pi minus a negative pi over 6 is 7 pi over 6, which is an answer where sine is a negative half. Does that make sense, guys? Yeah, so this will give you, so if you learn nothing else today, theta 1 equals arc sine of whatever will give you one answer, and then pi minus arc sine of the whatever you got the first time around will give you the second answer. Cool? Okay, so here we go. Let's tackle this question here. This one, you'll see that you won't need any formulas. You just use logic. Ready, guys? I'm going to move the 1. Sine 3/2 x equals 1. Can we do that? If you can do that, you got at least 20% credit. Next, what do I got to do? Inverse it. Perfect. 3/2 x equals, or you can say arc sine or inverse sine of 1 plus 2 pi n. Now you're at 30% credit. This only happens one time on the unit circle. What is the radian where arc sine is a 1? I know you guys are visuals, so here you go. Pi over 2. So 3/2 x equals pi over 2 plus 2 pi n. You're getting really close to half credit. I want to get the x by itself. You can say divide by 3/2, but I think it's better to say multiply by the reciprocal. Multiply by 2/3. Multiply everything on the right side by the same thing, 2/3. So here we go. X equals, okay, I'll slow down. So 2/3 times pi over 2, the 2's cancels out. That's going to be pi over 3 plus 4 pi n over 3. Once you get your general equation, that's half your credit. You got 50% of the credit. That's how I break it down when I do first ones. Cool or not cool? Now, to get your full credit, all you got to do is give me the answers. So they want all the values between what and what? 0 and 4 pi over 3. You notice that the 4 pi, remember, n is always an integer. You notice that you have plus 4 pi over 3n. Well, since pi over 3 is already positive, any positive number plus 4 pi over 3 is going to take me outside my domain. This one's only going to have one value. Just pi over 3. When n is 0. How do we feel? Did you guys already know all this stuff, or this is the first time? Okay. Wait until you take a class called Complex Analysis for you math majors. That one's going to blow your mind. If you decide to go that route, I don't know. It's actually a really fun class. All right. You guys ready? What are they, what? Yeah, eventually. All right. Let's see if we can do these with just logic. Let's see. So I have tan x equals square root of 3. X equals arc tan square root of 3. And I guess I kind of don't want to write plus 2 pi n. Let me tell you why. On the unit circle, I guess okay, put your pencils down. Let's just talk. So if I told you, where is tan equal to 1? Because that's a simple one. I hope it's a simple one. Tan is equal to 1 in quadrant 1 and in quadrant 3. What is the radian that will get me a 1 for tan? Pi over 4. Perfect. Yeah, because the x and y are square root of 2 over 2, square root of 2 over 2. Correct? And in quadrant 3, they're the same, but they're just negative, and negative divided by negative is a positive. I want you guys to recognize this. Do you see that this distance right there is just pi? Yeah. So I am tempted to just write plus pi n, and this will give me all my answers because I just keep adding pi. I'm right there. I keep adding pi. I'm right there again. Do you guys see what's going on there? Yeah. So if you write plus pi n, you'll get all your answers. Yay or nay? Yay. Perfect. Now you can write, guys. It's for all tans are like that, all of them, and also all cotangents are like that. Okay. All tans and all which ones? Cotangents. All tans and all cotangents repeat every pi. Just pi n. Oh, okay. All right, here we go. x1. Well, I guess you just need one x, so you don't even need to put x1 because there's not going to be 2. Where is tan square root of 3? So in order for tan to be square root of 3, I'll write it over here. Tan x equals square root of 3. In order for this to happen, guys, I need the numerator to be square root of 3 over 2, and I need the denominator to be a half. Remember that tan is what over what? Y over x. So where's the y coordinate? A square root of 3 over 2. And where's the x coordinate? An x. An x. Where's the x coordinate? A half.
Pi over 3.
Pi over 3. So pi over 3 plus pi n will give me all the answers. So let's get them all. X equals pi over 3 is the first one, comma. Chavez, how do you add it really fast? Like this. Put a 3, put a 3. 3 pi over 3 is just pi. 4 pi over 3, which is not a shock to you. You guys should be okay with the first two. Okay, and then 3 plus, okay, yeah. 7 pi. Just keep adding 3 pi to the numerator. Yep. Let's see, 4 times 3, all the way to 12 pi. Oh, 4 times 4. 16 pi over 4. Oh, times 3. 12 pi over 3. Yeah, that was up. So there it is, guys. How do we feel? Yeah. So do you guys think you guys can tackle this one? All right, let's see. First thing you do, I guess first write the expression. Tan 6, that's a 6, 6, 7x plus 1 equals 0. Move the 1 to the other side. Tan 6, 7x equals negative 1. Now what? Yeah, no, don't say the word reciprocal.
Inverse.
Inverse or arc.
Alright.
6/7 x equals arc tan of -1 plus pi n. I would stop right here and I would say, where is arc tan equal to -1? Bless you. It doesn't matter which one, as long as it's in quadrant 2. So which one? Or you can say also negative pi over. No, not over 3. It's 3 pi over 4.
And then,
But the pi n's going to give me all the answers, so don't worry about getting the other one. Yeah, don't worry about it. No, she was going to say the other one in quadrant 4, but you don't have to worry about it because if I keep adding pi, you'll get all the answers. Now I want to get x by itself, so what do I got to do? Multiply by the reciprocal. If you have colored pencils, this is how I would use them. X equals, let's see, nothing reduces. Nope, 7, 14, 21. 21 pi over 24. Oh yeah, which is, oh yeah, we could have done this. 6 goes into 3 2 times. So 7 pi over 8 plus 7 pi n over 6. We're okay so far, guys?
yeah.
All right. Let's see. We want all the answers between, and I think I made a mistake when I did this one. I think I meant to say between 0 and 7 pi over 6. Is 7 pi over 3 a bigger number or a smaller number than 7 pi over 6? It's a bigger number, so maybe we should leave it in there. Okay, let's leave it in there. X equals 7 pi over 8 for sure is an answer. Now what? Should we get a common denominator? Yeah, times 6 over 6 times 8 over 8. So let's see, what is this? X equals, what's 7 times 6? What's 8 times 6? Yeah, I should have done that one, but I already started with this one. Okay, well, I already started. What's 7 times 8? I don't really like it, but that's fine. Add them up, and then we'll reduce it. 56 and 42, 56, 66, 76, 86, 96, 98. 98. I got 98 pi over 48. Oh, you reduced it already? Okay. So 98 pi over 48, yeah, you're right. 49 pi over 24. Is 49 pi over 24 inside this 7 pi over 3? I don't know. How do you check it?
I'm going to make it decimal form.
Yeah, common denominator. That's a 24. 3 times what gives you 24? So multiply this by 8 over 8. What's 7 times 8 again? So 56 pi over 24. So yeah, it's in there. That's just some arithmetic. Sorry for putting in a hard one. I mean, I guess it wasn't too hard. It's just cumbersome. Both of those answers are in there. Sorry, guys. Next time I'll make it prettier. What's up? No, leave it alone because we're gonna have decimals. All right. Can we still take some more or no?
Yeah, I mean,
Yeah, let's keep going. We're smart. We're smart. You're smart, guys. All right. So the whole point of this last one here is I want you guys to see that not all of them are going to be perfect coordinates. So here's one where it's not a perfect coordinate. You can, if you want, write 1/4, but does tan ever equal 1/4? No. The perfect coordinates I have is 1 square root of 3 or 1 over square root of 3, which is square root of 3 over 3. So if you don't see any of those three, then that means you're going to have to just use your calculator. So here we go. X equals arctan of 0.25 plus pi n. You take your calculator, and you're literally just going to go second arctan, 0.25, enter. So I got 0.2449. X equals 0.2449 plus pi n. So my answers are, my first one, 0.2449. My next one is going to be that plus 3.14, or plus pi. So I'm just going to go plus pi, push enter, 3.3865. 3.3865. And that's it, because if you add another pi, well, you're above the 2 pi there limit. How do we feel, guys? Thanks. That's actually one of my better ones. I messed it up. All right. The last two. Okay, I guess before we finish up, we're almost done, guys. We really are almost done. If you want formulas, there they are. If you want formulas, there they are. And this is supposed to be you guys talking in quotes. I want formulas. Can I please have formulas? Here it is, guys. Arc sine, notice that here it is in radians. Here's equation 1. Here's equation 2. Remember where that pi minus whatever came from. We derived this from scratch. Now, look what they have. They have it up here in degrees as well. So the author, whoever, well, I know who the author is. This is Mr. Forrester who created this one. The author likes to use theta for degrees and x for radians. It doesn't matter, guys. Cool? Okay. So here we go. Let's do these last two. And there's no formulas for these. We're just going to do it by what we know. So cosecant x, square root of 2 cosecant x equals 2. Divide by square root of 2. So cosecant x equals 2 over square root of 2. Now you got two options. You can take the reciprocal. Yes. Or you can get the answer immediately from here. So what's the reciprocal cosecant? Sine. So you could write sine x equals square root of 2 over 2. And now you choose. Which route do you want to go? Route number 1 or route number 2? Number 2 is a lot easier, I think. Do you guys see that, how we did it? All right. So now x equals arc sine of square root of 2 over 2 plus 2 pi n. x1 equals, what's the first one where sine is square root of 2 over 2? Pi over 4 plus 2 pi n. What's the second one? 3 pi over 4. You can write pi minus pi over 4, but that's 3 pi over 4. Now let's get all our answers. X equals pi over 4 is the first one. 3 pi over 4 is the second one. Take the pi over 4 and add, let's go ahead and get a common denominator here. So times 4, so turn that into 8 over 4. 8 over 4, 8 over 4. So 8 plus 1 is 9 pi over 4, comma 8 plus 3. 11 pi over 4. And I believe that's it, because if you had another 2 pi.
Wait, no.
Actually, we were looking between 0 and 2 pi. So, sorry. That's fine. I apologize, guys. Don't get mad. Don't get mad. I'm like, man, you're making me learn more. I didn't see the domain. Sorry for making us work more. All right. I'm looking at it this time now. Before I even start, I'm looking at it now. So I'm only looking between 0 and 2. So before, do you immediately want to take the inverse of that? No, I think it, yeah. So that says cosecant 4x equals negative 2. No, oh, the reciprocal. I should have said reciprocal. That's a better word. Do you want to take the reciprocal of that? Yes. Sine, keep the argument. 4x is the argument, equals a negative half. This is a perfect coordinate on the unit circle. So here we go. 4x equals arc sine of negative half plus 2 pi n. Now I'm going to write 4x1 equals, give me the first one where sine is a negative half. Do you guys remember? 7 pi over plus 2 pi n. 4x2, what's the one in quadrant 4? Yep. How do we feel? Don't worry, we're almost done, guys. Now I'm going to divide everything by 4. So I'm taking the 4x1, divide by 4, place it right next to the 6 there, divide by 4. So x1 equals 7 pi over 24 plus pi n over 2. And we're going to talk about how do we know what's what. x2 divide by 4, divide by 4, divide by 4. So 11 pi over 24 plus pi n over 2. Don't worry, we're almost done. Catch up to here. Chavez, this says between 0 and 2, and there's a pi on it. How am I supposed to do this without a calculator? You can. Just look at the relative size of the pi's. So you can round pi down to like 3. So 3 divided by 2, so this is approximately 1.5. And this is approximately 1.5. Does that make sense, guys? So think about, let's say, what is this? Well, 7 times 3 is 21, and 21 over 24. So this guy is really close to 1. Not quite, but close to 1. Do you guys see what we're doing there? So, Chavez, what did you do? I just made pi equal to 3, and then 7 times 3, 21. 21 over 24 is close to 1. So I know that I'm not going to add 1.5 because 1 plus 1.5 is larger than 2. Does that make sense? So one of my answers is 7 pi over 24. Let's see, 11 times 3 is 33. 33 by 24 is a number smaller than 2. And the other answer is 11 pi over 24. And you do not add the pi over 2. How do we feel? Yeah, and there it is, guys. We just did a whole bunch of math without, I don't know, I think we're still in good shape. Like, do you feel like you have a headache or anything? All right, so just take care of, there's a UH quiz. If you want to take a break, that's fine. It's called solving. Yeah, we did. Good job. You guys did good. Yes, there's no such thing. Teachers don't have favorite. Do teachers have favorites?